almost ready to hit the road. Elon Musk's company rolling out the futuristic electric pickup over the weekend.
Tesla just dropped a huge update on its Cybertunnel project, and it's bigger than anyone expected. For years, Elon Musk's vision of underground high-speed transit has been inching forward, but this latest development could finally bring it to life in a way that revolutionizes urban travel. What's new? Faster, more efficient tunneling technology, a potential expansion of the Boring Company's network, and even a game-changing twist that could integrate with Tesla's self-driving fleet. Could this be the future of traffic-free, high-speed transportation? And when will we actually see it in action? Let's break down the latest Cybertunnel update and what it means for the future of travel. Tesla's Cybertruck production. Streamlined with the Cybertunnel. Tesla's Cybertrucks are now flowing through the Cybertunnel at Giga, Texas, marking a new phase in Tesla's innovative production and logistics strategy. Drone footage captured by Joe Tetmeyer revealed a batch of freshly manufactured Cybertrucks emerging from the underground tunnel, exiting through a Cybertruck-shaped opening complete with its signature light bar. These vehicles roll off the general assembly floor at Tesla's massive Gigafactory in Texas and immediately enter the underground passage. They travel beneath a divided highway and reappear on the other side in a staging lot, where they receive final inspections, software updates, and a full charge before being loaded onto transport trucks for delivery. This underground route bypasses surface-level congestion and streamlines the transportation of vehicles across Tesla's rapidly growing facility. However, at this stage, the Cybertrucks are still being manually driven through the tunnel. While Tesla has designed the Cybertunnel with automation in mind, the system has not yet transitioned to fully autonomous vehicle movement. Instead of the trucks driving themselves, human drivers still move them between the assembly line and the staging lot. Elon Musk's Boring Company constructed the Cybertunnel in 2024 using its latest Proof-Rock 3 boring machine. The excavation began nearly a year ago and was completed by June, when the tunnel breakthrough was achieved inside Tesla's newly constructed southern extension at Giga, Texas. This extension serves a dual purpose. It functions as the final assembly and quality control hub for the Cybertruck, while also housing a massive water-cooled supercomputer data center dedicated to Tesla's full self-driving, FSD, and autopilot development. The tunnel plays a key role in Tesla's long-term vision of optimizing its production process by integrating automation into vehicle logistics. Currently, the Cybertunnel's main advantage is reducing the time it takes for Cybertrucks to move from the assembly line to the delivery staging lot. The distance saved is minor, cutting just a few minutes off the journey. However, Tesla's real goal is much bigger, eliminating the need for human drivers in this process altogether. The push for full automation. If Tesla can successfully implement FSD within the Cybertunnel, it would revolutionize how vehicles move within the factory. Instead of workers manually transporting each vehicle, Cybertrucks could autonomously navigate from the factory floor to the staging lot without human intervention. By eliminating human-driven transport within the Gigafactory, Tesla expects to save approximately 240 seconds of production time per vehicle. When scaled across tens of thousands of Cybertrucks, the time and labor savings become a major efficiency boost. This transition to autonomy would not only free up workers for other tasks, but would also serve as a major milestone for Tesla's self-driving technology. The Cybertunnel is an ideal controlled environment for Tesla to refine its FSD capabilities, allowing vehicles to operate autonomously in a predictable, enclosed system before rolling out similar automation at larger scales. Although Tesla has not provided an official timeline for when the Cybertrucks will begin self-driving through the Cybertunnel, industry insiders speculate that the transition will happen in the first half of this year. This shift would mark a significant breakthrough, proving that Tesla's vision of autonomous production logistics is becoming a reality. implications for the Boring Company's other projects. Beyond Tesla's internal use, the success of the Cybertunnel could have broader implications for the Boring Company's transportation solutions. Currently, all Tesla vehicles operating in the Boring Company's Las Vegas Loop system at the Las Vegas Convention Center are still manually driven. This manual operation has significantly limited the efficiency of the Loop system. Passengers using the Loop experience frequent stops at red lights and unnecessary wait times, slowing down what was intended to be a seamless underground transit network. The introduction of fully autonomous driving in the Cybertunnel could serve as a proof of concept that would accelerate the adoption of self-driving Teslas within the Boring Company's tunnel projects. If Tesla successfully automates Cybertruck movement through the Cybertunnel, it would strengthen the case for deploying similar AI-driven automation in other Boring Company tunnels. In Las Vegas, a fully autonomous loop would drastically increase efficiency, reducing delays and allowing the system to operate at its full potential. Tesla and the Boring Company are working toward a future where underground transportation and autonomous driving are seamlessly integrated. The Cybertunnel is just the first step in testing how AI-powered vehicle movement can optimize logistics within a large-scale production facility. If successful, this model could be expanded beyond Gigafactories. Future Tesla production facilities could be designed with built-in autonomous underground transit systems, eliminating inefficiencies and maximizing production speed. The same principles could also be applied to urban transportation, where Tesla vehicles could autonomously navigate tunnels built by the Boring Company, reducing traffic congestion and streamlining city travel. While Tesla's Gigafactory in Texas is already a high-tech production hub, the implementation of self-driving Cybertrucks within the Cybertunnel would take automation to an entirely new level. As Tesla continues to refine its FSD technology, its impact will extend far beyond personal vehicles, transforming manufacturing, logistics, and urban mobility. The future of automated production, Tesla's Cybertunnel at Giga, Texas, is inching closer to its full potential, promising to revolutionize vehicle logistics. Right now, we're seeing Cybertrucks emerging from the tunnel, but they are still being driven manually. The real breakthrough will come when Tesla enables full self-driving FSD within the tunnel, allowing Cybertrucks to transport themselves from the assembly floor to the staging lot with zero human intervention. This tunnel, constructed by Elon Musk's Boring Company, was designed to streamline Tesla's production process. Instead of dealing with road congestion and relying on human drivers, Tesla envisions a fully automated underground system where vehicles move themselves seamlessly from production to delivery. By eliminating manual driving, Tesla aims to save approximately 240 seconds of production time per vehicle. That might not sound like much, but when applied across tens of thousands of units, it translates into massive efficiency gains. Right now, the Cybertunnel is operating with human drivers, but industry insiders expect Tesla to switch to self-driving Cybertrucks in the first half of this year. If successful, this could mark the beginning of Tesla's larger vision for autonomous logistics, not just for factories, but potentially for urban transportation as well. The success of Tesla's Cybertunnel could set the stage for broader applications of underground transportation. Right now, the Boring Company's Las Vegas Loop still relies on manually driven Teslas, which significantly limits its efficiency. Passengers riding the loop often experience unnecessary delays, with long waits at red lights and congestion at boarding stations. If Tesla proves that autonomous Cybertrucks can operate safely and efficiently in a controlled tunnel environment, it could pave the way for fully autonomous vehicles in Boring Company tunnels. Instead of waiting for human drivers, Tesla vehicles could navigate underground systems using AI, dramatically improving speed and efficiency. This would make the Boring Company's projects much more attractive to cities looking to alleviate surface-level congestion. Instead of building traditional subways, urban planners could opt for cost-effective, AI-powered tunnels that transport people and goods seamlessly underground. Inside Tesla's underground transport system, Tesla has always pushed the boundaries of automotive innovation, but this time they're taking it underground, literally. Beneath the sprawling gigafactory in Texas, Tesla has built a secret weapon in its quest for manufacturing efficiency: the Cybertunnel. This underground passage isn't just a shortcut, it's a glimpse into the future of vehicle production, where automation and logistics work together in ways never seen before. For years, Tesla has focused on vertical integration, streamlining its production to minimize reliance on third-party suppliers and reduce inefficiencies. But now, the company is extending its reach below ground, using tunnels to move Cybertrucks directly from the factory floor to the delivery staging area without ever touching a public road. This underground system could fundamentally change how Tesla, and potentially the entire auto industry, approaches manufacturing logistics. At first glance, it might seem excessive for Tesla to dig a tunnel just to move Cybertrucks across its own property. After all, couldn't they just drive the vehicles above ground like every other car factory? The answer lies in Tesla's obsession with efficiency, automation, and innovation. Giga, Texas, is a massive facility, and moving vehicles across it takes time. The Cybertunnel eliminates obstacles like traffic congestion, weather delays, and inefficiencies in manual transport. Instead of workers driving each Cybertruck to the staging area and returning for another, Tesla envisions an automated system where the trucks move themselves using full self-driving (FSD) technology. By reducing the time needed to transport Cybertrucks, Tesla saves labor costs and accelerates production output. The company has reportedly calculated that this underground system could shave up to 240 seconds off each vehicle's transfer time. While that might not sound like much, multiply that by tens of thousands of vehicles, and the savings become monumental. How Tesla's Cybertunnel works. The Cybertunnel starts at the production floor of Giga, Texas, where Cybertrucks roll off the assembly line. Instead of being driven across a highway to reach the delivery staging area, they descend into an underground tunnel. This tunnel, dug by Elon Musk's boring company, runs beneath the Gigafactory, avoiding traffic, intersections, and external logistics bottlenecks. Recent drone footage shows Cybertrucks emerging from a Cybertruck-shaped exit at the end of the tunnel, making their way to the final quality control checkpoints before being loaded onto delivery trucks. While Tesla employees are currently driving the vehicles manually through the tunnel, the long-term vision is to eliminate human drivers entirely. If Tesla can integrate full self-driving technology into this underground transport system, the Cybertrucks could navigate the tunnel autonomously, reducing labor dependency and making the process even more efficient. It would mark the first time that Tesla's self-driving software is used for internal factory logistics, potentially paving the way for fully autonomous production lines in the future. In 2024, the Boring Company's Prufrock 3 boring machine began excavation beneath Giga, Texas. By mid-year, the tunnel was complete, seamlessly linking Tesla's production floor to the staging area. The construction wasn't just about digging a hole. It involved precise engineering to ensure that the underground passage could support the weight of the Cybertrucks while integrating seamlessly with Tesla's existing infrastructure. This tunnel serves as a proof of concept for Musk's larger vision. If Tesla can successfully integrate automated vehicle transport into its underground system, it opens the door for more tunnels at other gigafactories, or even external shipping hubs that could streamline delivery logistics beyond just the factory grounds. Could Tesla's underground network reshape vehicle manufacturing? Tesla isn't just building cars, it's redefining how cars are built. The Cybertunnel is part of a larger trend in factory automation, where companies use cutting-edge technology to improve efficiency. But what if this underground transport system becomes standard across Tesla's global operations? If Tesla expands this tunnel concept, other gigafactories could adopt similar underground networks, moving vehicles, parts, and even raw materials between different sections of the facility without surface-level delays. This could allow Tesla to create an almost fully automated production cycle, where vehicles move seamlessly from one phase to another without human intervention. More broadly, if the Boring Company's tunneling technology becomes faster and cheaper, Tesla could start using tunnels outside of factories, connecting manufacturing hubs directly to shipping ports, warehouses, or even customer delivery centers. Imagine a world where Tesla's entire supply chain moves underground, avoiding traffic, inclement weather, and traditional logistical headaches. Tesla has a history of pioneering technology that later becomes industry standard. When they introduced Geiger casting, it revolutionized vehicle assembly. When they built self-driving software, other automakers rushed to catch up. The same could happen with underground transport. If Tesla's Cybertunnel system proves successful, other manufacturers might rethink their approach to factory logistics. Major automakers with large production campuses, like Ford, Toyota, and Volkswagen, could implement underground transport networks to streamline internal logistics. Companies focused on autonomous vehicle technology, such as Waymo or Cruise, might also see this as an opportunity to expand self-driving software beyond public roads and into industrial applications. The Cybertunnel is more than just a cool experiment. It's a potential game-changer for the entire automotive industry. The challenges Tesla faces. While the Cybertunnel sounds revolutionary, Tesla still has a few hurdles to clear before it reaches its full potential. For one, autonomous driving technology isn't quite there yet. While Tesla's full self-driving system has made huge advancements, it still requires human oversight. Transitioning to fully self-driving Cybertrucks in the tunnel will take time and rigorous testing. Another challenge is scalability. Tunneling isn't cheap, and while Tesla has deep pockets, expanding this system to other factories or even external shipping hubs will require significant investment. The key will be whether the time and cost savings justify further expansion. Then there's public perception. Some critics already view Tesla's self-driving technology as controversial, and adding underground automation to the mix might raise concerns about safety, reliability, and job displacement. Convincing the world that robot-driven Cybertrucks in tunnels are a good idea will require Tesla to prove its system works flawlessly. Despite the challenges, Tesla's Cybertunnel is a glimpse into the future of automotive production. With the potential to improve efficiency, reduce labor costs, and accelerate vehicle output, this underground network could become a key part of Tesla's long-term strategy. If successful, we could see gigafactories around the world connected by underground transport routes, linking production facilities with delivery centers and ports. We might even see fully autonomous factory logistics, where vehicles and parts move seamlessly without human intervention. The Cybertunnel isn't just about moving Cybertrucks. It's about redefining how cars are made, shipped, and delivered. As Tesla continues to push boundaries, this underground transport system could become one of its most significant innovations yet. And if that happens, we may one day look back and realize that the future of vehicle manufacturing was always just beneath our feet. Tesla's gigafactories are more than just car plants. They are hubs of innovation designed to push the limits of modern manufacturing. With Giga Texas, Tesla has refined its production process to the point where raw materials enter one end of the factory and a fully assembled vehicle rolls out the other. This level of efficiency is unheard of in the automotive industry. Most legacy car manufacturers operate with multiple scattered facilities, each handling different stages of production. Tesla, on the other hand, has optimized its process by consolidating everything into a single high-tech factory. The Cybertunnel is just the latest example of how Tesla is eliminating inefficiencies and redefining how vehicles are built. While other automakers struggle to integrate automation into their supply chains, Tesla is already years ahead, creating a system that could eventually eliminate human-driven logistics entirely. Once the Cybertunnel transitions to full automation, it will serve as proof that Tesla's vision of AI-driven production is achievable. How traditional automakers move cars inside their factories. The automotive industry has long relied on well-established manufacturing processes to move vehicles through factories, from the initial assembly to final delivery. While Tesla has introduced its innovative underground Cybertunnel, traditional automakers like Ford, Toyota, and General Motors continue to use conventional transport systems to move their cars from production lines to delivery points. These methods, although effective, come with certain inefficiencies that Tesla aims to eliminate with its high-tech approach. Most automakers utilize conveyor belts, automated guided vehicles, AGVs, and overhead cranes to transport partially assembled cars through different stages of production. Once a vehicle is fully built, it must be moved to staging areas where it is prepped for delivery, either by being driven manually or using automated systems. However, most of these methods still involve considerable labor, space, and time. One of the most common methods used in factories is the conveyor belt system, which has been a staple of automotive manufacturing since Henry Ford introduced the moving assembly line in 1913. This system ensures that vehicles progress efficiently from one station to the next, with workers and robots handling different tasks at each stage. However, once the car is fully assembled, it must be transported out of the factory, something that still heavily relies on human drivers. Another method widely used is automated guided vehicles, AGVs. These self-driving carts transport car parts and sometimes entire vehicles from one section of a factory to another. AGVs follow pre-programmed routes using sensors and cameras to navigate the plant floor. While this technology has helped reduce human labor and increase efficiency, it is still limited to factory floors and does not extend to external logistics. Overhead cranes and pulley systems are also used in some factories, especially in high-volume production facilities where space optimization is crucial. These cranes lift partially built cars between different levels of the factory, reducing congestion on the ground floor. However, this method comes with safety concerns and is only applicable in specific sections of a plant. Once vehicles leave the production line, traditional automakers rely on large parking lots, ramps, and human drivers to move them to storage and transportation areas. This step is where inefficiencies begin to stack up. Unlike Tesla's Cybertunnel, which aims to eliminate these manual steps, traditional factories require significant space and labor to move vehicles around. How Ford, Toyota, and GM move vehicles compared to Tesla, Ford, Toyota, and General Motors have refined their vehicle movement strategies over decades, optimizing efficiency within their factories while maintaining traditional transport methods. Each company has its approach to handling vehicle logistics, but none have yet implemented an underground transport system like Tesla's Cybertunnel. Ford, one of the pioneers of mass vehicle production, primarily relies on automated conveyor systems and human-driven transport methods. In Ford's plants, conveyor belts move vehicles through different manufacturing stages, and once assembled, the vehicles are driven to designated holding areas by employees. Ford also utilizes rail-mounted skids in some facilities, allowing cars to be moved quickly across large factory floors. Toyota, known for its Toyota Production System, TPS, emphasizes lean manufacturing and waste reduction. One of Toyota's primary strategies for vehicle movement is just-in-time logistics, ensuring that vehicles and parts move only when needed, reducing storage space. Toyota employs AGVs and conveyor belts extensively, but still depends on human-driven transport for moving finished cars to shipping areas. General Motors, operating some of the largest automotive plants in North America, has integrated automated vehicle delivery systems in some locations. GM uses a mix of AGVs, robotic arms, and rail systems to move cars efficiently through their assembly lines. However, just like Ford and Toyota, GM still relies on large-scale parking lots and human-driven transport to move cars from factories to distribution centers. Tesla's Cybertunnel approach stands out because it eliminates the need for surface-level transport within the factory premises. Instead of manually driving cars to a storage lot, Tesla's tunnel system allows Cybertrucks to autonomously move from the assembly line to a staging area. This method reduces congestion, eliminates the need for large parking lots, and speeds up the vehicle delivery process. The major difference between Tesla and traditional automakers is the company's commitment to automation beyond just the production floor. While Ford, Toyota, and GM have implemented automation in their assembly lines, their post-production logistics still rely on outdated manual transport methods. Tesla's underground system could become a model for the future, demonstrating how logistics within a factory can be streamlined, cost-effective, and highly efficient. Why other automakers still rely on traditional transport methods. Despite the advantages of underground transport, most traditional automakers have not yet adopted a system like Tesla's Cybertunnel. Several reasons explain why companies like Ford, Toyota, and GM continue using conventional transport methods, even as Tesla pushes for innovation. One of the biggest factors is cost and infrastructure investment. Building underground tunnels requires significant investment in excavation, engineering, and tunneling technology. Traditional automakers already operate within massive, established factory complexes, and retrofitting an underground transport system into an existing factory would be extremely expensive. Since their current systems work well enough, automakers may see no urgent need to overhaul their logistics. Another challenge is scale and logistics coordination. Companies like GM and Toyota operate dozens of factories worldwide, each with its unique layout and design. Implementing a tunnel-based transport system across all facilities would require standardizing factory layouts and redesigning logistics operations, which is not an easy task. In contrast, Tesla built Giga Texas with the Cybertunnel in mind, integrating it from the start. Traditional automakers also prioritize flexibility. Unlike Tesla, which focuses on direct-to-consumer sales, companies like Ford and Toyota distribute vehicles to dealerships and regional warehouses before they reach buyers. Their logistics networks require cars to be staged in large lots before transport, making a tunnel system less practical. Since Tesla delivers vehicles straight to customers, its process benefits more from an underground transport system. Additionally, labor unions in the automotive industry play a significant role in decision-making. Automakers rely on thousands of workers to manage vehicle logistics, from moving cars within the factory to driving them to delivery points. A fully automated tunnel system could reduce the need for these jobs, making it a controversial topic within unionized workforces. Companies may hesitate to implement such systems due to potential conflicts with labor organizations. Finally, legacy automakers tend to prioritize incremental improvements rather than radical changes. The automotive industry is slow to adopt new manufacturing processes, as seen with the delayed shift to electric vehicles. While Tesla takes risks by implementing bold new ideas like the Cybertunnel, traditional automakers prefer to optimize existing systems rather than introduce entirely new methods. However, if Tesla's Cybertunnel proves successful, other automakers may be forced to reconsider their transport strategies. As production costs rise and efficiency becomes more critical, companies like Ford, Toyota, and GM may explore alternative solutions, including automated underground logistics. If Tesla's approach significantly reduces costs and speeds up production, competitors will likely adapt similar innovations in the future. While most automakers continue relying on conveyor belts, AGVs, and manual driving to move cars within factories, Tesla's Cybertunnel introduces a potential game-changer in vehicle logistics. By eliminating surface-level congestion and reducing labor-intensive movement, Tesla has set a new standard for factory transport. Ford, Toyota, and GM have strong production systems in place, but they lack the full-scale automation that Tesla is striving for. Their reluctance to change is understandable, given the costs and complexities involved in overhauling decades-old logistics networks. However, as technology advances and competition grows fiercer, automakers may have no choice but to explore new ways of moving vehicles efficiently. Tesla's experiment with underground transport could inspire a shift in the industry, pushing manufacturers to rethink how they handle factory logistics. If successful, the Cybertunnel could become the blueprint for future automotive production facilities, marking a new era of efficiency and automation in car manufacturing. Joe Rogan's custom Tesla Model S Plaid. While Tesla focuses on factory innovation, Tesla owners like Joe Rogan are taking customization into their own hands. Rogan, known for his love of high-performance vehicles, has transformed his Tesla Model S Plaid into a one-of-a-kind machine with the help of Unplugged Performance, UP. Tesla's factory designs are sleek and futuristic, but they don't offer much in terms of personalization. That's where third-party companies like UP come in, allowing owners to modify their Teslas with high-end performance upgrades and unique aesthetics. Rogan's Model S Plaid now features a 19-piece carbon fiber wide-body kit, which extends the width of the vehicle by 3 inches. UP paired this with their ultra-light UP03 forged monoblock wheels, measuring 21 inches in the front and 21.5 inches in the rear, wrapped in Michelin Pilot Sport 4S tires. This gives the car a more aggressive stance, while improving handling and performance. The aerodynamic modifications include a carbon fiber rear lip spoiler, a dramatic diffuser, and rocker panels with integrated airflow control. The car's original paint was also replaced with a pearl white finish that has subtle hints of blue, covered in a satin paint protection film for durability. The Tesla Model S Plaid is already one of the most powerful electric sedans ever made, boasting 1,020 horsepower. However, Unplugged Performance took it a step further by upgrading the braking system with carbon ceramic discs for improved stopping power. To enhance handling, they installed forged billet suspension arms, ensuring that the car remains stable and responsive at high speeds. Inside, Rogan's Model S Plaid received a complete interior overhaul, featuring custom-designed von Holzhausen white bamboo leather with black Alcantara accents. These modifications showcase how Tesla's electric vehicles aren't just about sustainability. They can also be tailored for high-performance enthusiasts looking for a unique driving experience. Tesla is also working on other major updates. Tesla's new Model Y launches worldwide. Tesla recently launched its redesigned Model Y in China, and now the rest of the world is getting its hands on the refreshed version of the best-selling EV. The new Model Y has officially started rolling off production lines outside of China, with the first unit in Germany receiving a special touch. All employees involved in the project signed the vehicle, marking an important milestone for Tesla's expansion in Europe. The launch series Model Y is currently available only as a long-range all-wheel drive variant. In the US, the price starts at $60,000, while Canadian buyers will pay around $85,000. In Europe, the vehicle is priced at €61,000. Despite the higher price tag compared to previous versions, the new Model Y has seen massive demand. Tesla has already received over 130,000 orders in just 16 days after the launch in China alone. This overwhelming response underscores the car's growing global appeal, solidifying its place as one of Tesla's most successful vehicles to date. Model Y's significant upgrades and hidden enhancements. While the launch series Model Y comes at a premium price, it offers a fully loaded package, including all available options and accessories. Tesla's improvements go beyond the surface, with up to 50% of the car's components being completely new. Early, hands-on reviews from automotive content creators have revealed that Tesla has fine-tuned nearly every aspect of the Model Y, from aerodynamics and battery efficiency to ride quality and software refinements. CarWow, Top Gear, and out-of-spec reviews have all provided in-depth analysis, with many noting that the updates go far deeper than expected. Tesla's Vice President of Finance, Sandil Palani, emphasized that the company remains committed to refining what is already the world's best-selling car. As Tesla continues to push innovation in vehicle manufacturing, the Model Y's ongoing evolution demonstrates the company's dedication to staying ahead in the electric vehicle market. The Model Y's global demand and future variants. Tesla's rapid success with the new Model Y has raised questions about future variants. While the launch series version represents a high-end trim, industry insiders expect Tesla to introduce more affordable versions in the coming months. As competition in the EV market intensifies, Tesla may release a standard range version at a lower price point, making the Model Y accessible to an even wider audience. Future updates could also include next-generation battery technology, further enhancing efficiency and driving range. With Tesla's continued investment in vehicle improvements, the Model Y is well positioned to maintain its dominance in the EV sector. The overwhelming demand from consumers suggests that Tesla's strategy of continuous refinement is paying off, keeping the Model Y at the forefront of the industry. Alright, so that's it for this video, and if you want to watch more amazing content like this, check out some of our other videos. Bye!